Go is a fairly young language. It was first released in 2009. And so it's meant to be kind of a, a replacement for C and C++, even though it's not really. We'll kind of talk about that. I don't want to, present this like I am some sort of expert in Go. I am not an expert in Go. I am, if I had to, classify myself as anything, I'm a Java developer. You'll see a lot of comparisons between Go and Java in this presentation. So I'm not an expert, but I will do my best to play one on video. So, all right. All right, so we kind of got through this part already. So we'll go through a language overview. We'll do a getting started kind of thing. I was originally going to try to do a live coding thing. We're not going to get to that. I'll just say that right up front. So. All right, so the details of Go. So it was created at Google by some familiar names, Rob Pike, Ken Thompson, and Robert Geismer. So Rob Pike and Ken Thompson, obviously if you went to college within the last 30 years and you studied programming, you learned about Ken Thompson at least, probably Rob Pike as well. So they go back to, the name is escaping me right now. But some of the first Silicon Valley companies, right? Ken Thompson and they both worked on Unix. Obviously, Rob Pike was responsible for Plan 9. And Ken Thompson he created B, contributed heavily to C, and so on. And Rob Geismer is a little bit younger, but he's also been responsible for a lot of the research that's going on at Google for distributed technologies. So again, intended to replace C and C++. It is very opinionated. Okay, and so when I say opinionated, I mean like tabs and spaces type of opinionated. I mean it's like literally some of that stuff is baked into the language. If you try to put your curly brace on the next line down, it will tell you you have done something wrong. Okay, so that kind of stuff. So it is has very strong opinions. It's got an extreme focus on simplicity, which seems contradictory when you're going down to the level of trying to enforce some of those formatting issues. But the spec. Okay, so if you were to compare it to the Java or Scala spec, actually did that here. So the Java spec is 780 pages, the Scala spec is 191 pages, and Go is 51 pages. Okay, so obviously some of the Java spec is bloated from years of trying to try to explain a lot of different things, but even Scala, which honestly I always describe Scala to people as somebody wanted to try to make a programming language where they use every key on the keyboard. That is, it's still 191 pages, but Go is fairly small. So why Go? It's statically typed. I'm not a dynamic typing guy, right? I thought Ruby was cool. I've done some Ruby, a little bit of JavaScript. But for me, when I'm building a really large project, I like static typing. I want my compiler to check a lot of the things that I'm doing to make sure I'm not goofing up. It is garbage collected. So going back to the plan of being a replacement for C and C++, if you're doing real-time stuff, garbage collected languages really are probably not a very good idea. Now, I caveat that with saying that Go, in their latest release, claims that their longest GC pause is 100 microseconds. So still super duper fast, and good for most everything that's not maybe flying a jet or something like that. It has excellent concurrency features. So they implement that with things called Go routines and channels. We'll talk about that a little bit later, but is anybody familiar with Akka? Anybody? Okay. So Akka is a way that they do this in Java or Scala, and this you'll see that this is very similar to Akka. Oops, wrong way. So it has surprisingly good tooling. All right. So when I say tooling, lots of times you're talking about IDEs and stuff like that. not necessarily IDEs, but they have a lot of command line tooling that helps you do things like formatting. You don't get a lot of choices. Again, very opinionated. Go format will format it the way that Go wants to format it, and you don't get a lot of choices about that. But this also got things like built-in documentation generation, sort of like Java docs. It's got, and there's a ton of things that are built by the third-party libraries that help you do things like implement code completion in your editors and stuff like that. So you can actually be very functional in Go, almost IDE level of functional with just Vim. Okay, and so when we look at code examples tonight, I'm going to be doing those mostly through Vim. It is not object-oriented. Okay, it sort of plays one on TV, but it is not object-oriented. So and that's not in the classical sense of object orientation. So you don't build. So they emphasize composability over inheritance. Interfaces are primarily behavioral. Okay, so when you create an interface in Java, pre-Java 8, where you had native methods, you would specify that there are methods that do certain things. They'll return certain things. So you got to specify the method signatures and things like that. But they don't really have a lot of data associated with them. Right? In Go, they have structs. So those are purely data. And then they have interfaces which sort of describe, and that's how they get some of the polymorphic kinds of traits. But their plan is to provide composability over inheritance. And it is very, very fast to compile. So half of your time, if you've got a small Java project, half of your time is spent waiting for the VM to spin up. Okay, that's not a problem with Go. And so I actually have I've helped out a little bit on an e-commerce framework. It's got about 17 megabytes of just code, right? So not talking about like caches and pictures and all that kind of stuff. Just code, and it takes about 4 to 5 seconds for that to build. So that's from clean. That's not, got a bunch of stuff cached or anything like that. And it will cross-compile support for all major operating systems and architectures. So, for example, if I'm building this on my Mac, all I have to do is specify a target operating system or chipset architecture, and Go will do the rest. All right, so why not Go? Now, these are some things that I'll try to remember to bring these up as we go along. Some of the opinions feel very arbitrary and opinionated for the opinion's sake. Okay, for example, the way that you expose methods and fields on a struct is not. It goes by case, for example, right? So I personally don't like that. It feels very gross when I first got into it. You kind of learn to sort of deal with that or be okay with it. It's not terrible, but it feels bad, right? So I tend to like things that are more declarative and explicit about themselves, and Go does some things that are implicit that don't feel great. So there are some inconsistencies in the grammar. I say it's inconsistent. It's not really inconsistent. It's just there's several different ways to do something. Like, it's not Perl bad, but it's, like for example, we'll talk about some different ways to assign variables. And I can see that getting sort of muddled and confusing if you're looking at a big block of code there. So they did try to do their best to help you out in terms of trying to prevent some of the likely situations, but it's not. In my opinion, it's not great. So I said one of the things that I didn't like is implicit exposure of field and functions. So in Java, for example, you would have public, private, package protected, that kind of stuff, right? In Go, you just have the name of the field or the function, and if it's capitalized, it's exported, and if it's not capitalized, it's not. Okay? So think lowercase private, uppercase public. So explicit error handling conventions. So they wanted to do this. They wanted to make sure that at every level of your code, you're handling errors. Okay. so everybody hated checked exceptions, and then so they went around and around trying to figure out the best ways to get around checked exceptions. And now we come back, and this is really like a lot of checked exceptions. The one difference is that unlike Java, which generates a whole stack trace, which can be expensive, these are just values. Okay. There are panics and things like that, but those are not typically for use unless you actually have extreme situations where you're actually going to exit the program. And go to the next one. There we go. All right, so go get started. Go get is one of the ways that Go actually has a built-in package manager. Okay, so where you might use Maven to download dependencies and things like that in Java. Nick, is there something like that in?
Yes.
Yeah, there you go. So there's things like that in C# as well, but Go has that built in to the language itself. So for example, if you were to download, check out something out of GitHub, and you typed go get, it would inspect all of your code, all the code that you brought down, and actually download all the dependencies that you need to be able to build it. And that doesn't use any external package files or anything like that. That just looks at the import statements in the code. Setup and configuration. Binaries are available for major desktop operating systems. Packages are available for most operating systems and package managers. So for example, there's one for Choco, one for Mac, Homebrew, and apt-get on Ubuntu. It's for Yum. It's got basically every flavor has some kind of package that's available for it. And they're actually very good at keeping them up to date. Java is a classic one for getting really out of date in the package management tools and having to do a lot of stuff. Half the time that's because of Sun's licensing stuff, but yeah. All right. Go relies on very little configuration, but it can be confusing. Go root. Now this is actually optional, but this would be like Java Home. So Go root is where the Go program is installed. That's just, like I said, I say it's optional. I don't have to set it on my machine, like it's not set in my execution environment. So, Go path is the most important one. This is your Go development environment. I don't think I know a lot of corollaries in other languages that are like this, but it's like basically the Go path contains Go's entire ecosystem of its dependencies and your code and multiple projects and all that kind of stuff. So, like I said, I don't know of a corollary in other things that are quite like that. Now, so this is sort of a convention with the way that you would set up a Go program. So you would have your Go path. Under Go path, there's 3 directories: a bin directory, a package directory, and a source directory. And then underneath that, the typical convention is to say this would look sort of like a URL. Okay, so for example, if your code is hosted at GitHub, it would be github.com/your username /the project name. Okay, it's just the way they chose to do it, and it actually does work pretty well. And that's where your project actually lives. Okay, so I was very confused about this for the longest time, could not figure it out, trying to apply everything that I already knew about software development to this, and it wasn't working out. So I thought that this was kind of an important thing to get up there. All right, so let's actually do something. Okay. So what I have here is just a directory on my machine. I'll try to do my best to be able to see this while I'm typing here. So what I'm going to do now is I'm going to make a Go path here. And then what I'm going to do is I'm going to export. I might want to do this here because this is really hard. So, okay, so I'm now in the right spot. Now I'm going to create the general directories that I would do. So this would be what you would do if you're setting up your Go path for the first time. So, okay. Now, underneath source. Now I don't have to use the GitHub convention. I can just create up a name here. So. Now I'm in my package environment, so this will be my project. So. All right, so the obligatory world here. Now, this file was not here a second ago. What happened was I've got a extension. I've got the Vim extension in Vim. So Vim actually knows that this is an empty Go file, and it's going to create all this stuff for me. So, so now that it's done that, now again, like I said, the tooling is actually quite good. The Vim extension is really just a thin wrap around Go's own tools. So I can do Go run, and then it prints out Vim Go just like you expect. I want to say. Spelled that wrong, but I can't really see it.
Yeah, it's WPRLE.
So that's all there is to that. Okay, so that is, I guess I'll talk about this here. Whenever in all of your projects that will have a command line, you will have a package main and a function main. When Go tries to run a file, it's going to look for those things, and so that's what it does. Now, if I do a Go build here, now I created a binary file. Right here. Notice that's not named main or anything like that. That's named after the package that I'm in. So that rush move is the one level up directory, and that's going to be, I did a package main for that other thing, but for everything else it will be that rush move will be the package. All right, clear as mud.
You just type rush move right now on the run.
Yep. All right. So that is all it takes to create your Go environment. Now you're really actually ready to write code at this point. Okay. So we talked a little bit about the command line tools. Go get will download the dependencies for you. Go format will format your code. Go doc generates documentation, sort of like Java doc or anything like that. There are extended tools here, and there's a ton of stuff there, like code coverage and auto completion and all that kind of stuff. Dependency checking. It does. What else is in there? Just a ton of stuff that you would normally have in a like if you start up Eclipse, right, or any language with really good tooling, you would have those things available to you in the IDE. Go doesn't depend upon the IDE. It actually implements a lot of that stuff from the command line. So Go code is the auto completion provider. Go tags, so that's a C tag thing. So if you're come from the C world and you're used to building those tags out and being able to use that in your editor, it does that. Go def will actually, this is actually looking up the definition location wherever you declared something, right? Glide, now, this is sort of a new thing. Starting in Go 1.5, they introduced vendoring. So last session we talked about some of the complications with NPM and how it can really turn into a real problem with dependencies and stuff like that. Now you can imagine that if we installed all of the dependencies that we were ever going to use in our Go path, that could be a problem, right? Then you have one project that depends on one version, and another project that depends upon another version, and you're kind of spinning off into the same sort of world. The vendoring libraries allow you to sort of get around that, where your dependencies are all stored in your project, and so that's actually a good improvement. The problem is that GoGet isn't great with that. It doesn't do that for you. So they're starting to develop some of these package managers, and Glide is one of those. All right. So, like I said, Glide manages vendor packages. It does not change the regular Go workflow. So, for example, if I wanted to type Go build, once I downloaded all the packages, because Go knows what the vendor directory is, it's able to find what it needs and be able to build things. So Glide is one of the more popular ones right now, and so that's the one that we're going to talk about. So I've already installed Glide on my computer, so I'm just going to be able to use it. You can get it either by the package manager, like I installed mine through Homebrew. You can also use GoGet, and it will actually bring down the binary and install it in your Go path. And then you're able to use it for as long as that Go is set. So what Glide does here. Oops. All right, so that will initialize my package file. Now we're talking about something here that's sort of like a pom.xml or something that defines the things that you're going to use. You can see there that I now have a glide.yaml. Okay. Now I'm going to add a dependency. So now, I created a lock file too. So that lock file, so you can see how that command added this this dependency to the right spot here. It knows what the package is, and it kind of gleans all that from where it's at when it was run. Now the other thing that we now have is a vendor directory. And that is the source code for the dependency that I added here, okay? So cool thing about that is now you can go in there and you can read all that code. You don't necessarily need great documentation because all that source is available for you right there. Okay, and just another way of looking at this. So that's just another look at that directory. So this is the Glide lock file. This is actually using the hashes on these dependencies so that it actually locks you down. You can do a manual upgrade to those things, but for the most part, it's locking you into the version that you used when you got that. Okay. All right. All right, so a package is the most basic way Go code is organized. We talked about the directory structure is a URL by convention. Okay, so like I say, that's not enforced by anything. You can see that we did something a little bit different in the program that we're working on here. It's just one of those things that if you plan to put it someplace like on GitHub, it's a good thing to think about before you actually start your project. The entire namespace is not required when importing packages like Java, but that's actually not correct. I'm not sure why I had that bullet point on there. You do use the full namespace when you do that. It's just that when you're actually referring to methods or structs that are on that, you don't have to refer to the entire thing every time. So for example, our package here is called boss.rushmove. I wouldn't have to include that every time I wanted to use with that package. It will simplify that, and I can show you that later. The Go compiler will not allow unused imports or circular package references. So package A refers to package B, and package B refers back to package A. That the Go compiler will not allow that. It's also extremely picky about package imports and variables that are unused. So typical dead code, right? Large, older code bases, they end up kind of having all this crap in there that just is puffed and takes extra cycles for you to look through it and say, that's not even used anywhere. I don't even know what that's for, right? So Go actually sort of forces you to take that out of your stuff. Now there are ways to get around that, but it's very obvious when you're looking at your code that something is not used. So that's actually a really good feature. So Go has several ways to declare a variable. Explicit declaration. So this would look something a little bit like JavaScript up to the end of food there. Then you define the type that food is. You can also infer, it has inferred. So for instance, the example you could do, and this is kind of what I was talking about earlier about a little bit inconsistent. So all of these are valid. This right here, I'm not a big fan of that really. I would rather kind of have one way to do this. These two are essentially the same. The difference here is this little guy right here having the colon on the front. Now, what that looks like in, once you start actually writing code there is that you got one guy with a colon equals, and then everybody else with equals afterward if you're going to do something like reassign that variable. So I think that's a little bit inconsistent. Feels kind of icky when I'm sort of like looking at the code and trying to sort of grok it at a really deep level. But it's not that bad. And one of the reasons why they chose to not just let you do that whenever and have Go figure out when it's actually an assignment or when it's a declaration is they didn't want you to use colon equals for everything. So that's a design decision they made. And I'll tell you the thing is that when I look at some of that kind of stuff and I say, yeah, I don't really like that. If I was designing the language, I probably wouldn't do that. I have to take that with a grain of salt because I'm not the guy who designed C or B or Plan 9 or contributed to Unix or anything like that. So I'll sort of accept their opinion until it proves itself to be not valid. So, all right. So rules on declaring variables. A variable may only be declared once. Variables can be reassigned. Any variable that is declared but not used will result in a compiler error. So I think that's fantastic. Anybody who's managed a large legacy code base would love something like that. And there are things, languages that you can sort of enforce that. You can do static analysis and that kind of thing. But when it's just the compiler won't let you, there's an extra level of prevention there. Variable scope is enforced the same way as other C family languages. So if you were inside curly braces, basically you define scope. If you declare a variable inside of the curly braces, you are not going to, that variable will not be available outside of the curly braces. So I think most everybody here is, anybody that's a foreign concept to them. I mean, if you develop in C# or Java or anything like that, that's a pretty standard thing. All right, so before we get to that, let's take a look stuff here.
Might you zoom in with that remote button?
Well, I'm going to,
Switch back and forth.
yeah, so I will zoom in here. Hopefully you guys are able to see this. So what I'll do here is I'll just zoom in like so. This works a lot better on a. No, not on these. Works a lot better on a. You're not sharing your screen. Something about the screen sharing doesn't like that. Okay, let's try. Let's try this. This one is easier for me anyway. All right, so now let's try this. There we go. All right, so that, if you couldn't see it before, now you should be able to see that. Okay, so what we'll do here is we'll do a little bit of variable. So I'm going to cheat here. All right, so you can see the variable declaration here. So I've sort of assigned message, and that's a string. If I was to try to assign message to an int, obviously the compiler would complain, and I would not be able to do anything. We also see here that both of those examples of how I was declaring variables previously, those types are inferred. So if I was to go here, so now if I was part of the Vim plugin there will actually run a build on the code and tell me that I've got problems. So the problem here is cannot use this will fail type string. Int assignment. This should all be fairly obvious. And you'll also notice that when I actually save the file, it automatically formats it. All right. Now, Go is actually very, very picky about variables. We'll see that a little bit later. But for example, in Java, you can just sort of concatenate an integer to a string, and it will just sort of figure that out. Go actually wants you to convert that integer into a string in order to actually do something with it. And before I get too far here, this right here, this is an example of where you're trying to redeclare a variable versus a reassignment. So this reassignment down here, a equals 10, and that's just fine. This colon equal means that it's a declaration. So when I try to run that, I get a failure, except not where I was expecting it. There we go. And then the failure is basically that it can't have, the error is no new variables on the left side of colon equals. Sorry for the. There we go. Go away, that guy. So you can sort of see it. Unfortunately, there we go. So if you can see down here at the bottom, it will actually give me the error. And it went away. All right. So if I was to try to run this. Oops. So here, I've got my output. as I would expect it to be. All right, so that covers declarations. Questions about that?
Can you have multiple variable assignments on a single line, like you do in a
Yep.
lot of other languages?
You can do that, for example, yeah, so if you wanted to do X, Y, oops, I think I did. Oh, this is the funny.
So now they're all strings.
So the error that's actually coming up with right now is that it says Z is declared and not used.
Oh.
So that's the, like I say, it is very picky about trying to declare variables that you don't actually use. The trick there to get around that is if I was to do let's do it on a packaging or something. Okay, so if I was to save this, it will say that time is not used. What I can do here is put a little underbar, and everything is okay. The caveat there is I cannot use time while it's got that underbar there. That's just a special character that says don't assign that to anything. That can be used in multiple different places as well. So for example, if I was to call a function, so let's say and I'll give it an error. There's an error. And let's just say now, where's so if I was to call that, I can assign this. Oops.
We have a variable name.
Oh. So if I don't do anything with that normally, like for example, if I just make this an error, it will complain at me and say that's undefined. Right? Oops. This. Okay. So it's error is declared and not used. So So and then that's the error down here. Oh, jeez, this is not great. All right. But basically, take my word for it. That's what it does.
How's
Okay.
it different than a comment?
What's that?
How's
It's
it
not.
different?
It's
Okay.
not. That's the funny thing. This is one of those sort of weird oddities of the language. Is that I could just do this. Same thing, right? Now the error goes away, and I can do things. But for example, if I wanted to get the key and the value from a map, it'll actually return both types. If I had two return types from my print message there, it would give me both types back. One of them can be an error. This is one of the ways that error handling is done. So it'll pass back multi-value types. But if I want to ignore it, that's kind of where I would use something like that. So for example, if I'm doing looping over a set of map entries or an array, that array will give me back the index and the value. If I don't care about the index, I can just do an underbar variable. Just ignore that. Otherwise, I would actually have to do something with that variable. Does that make sense?
Sort of slightly different than a comment.
Slightly different, but yeah, in the case that I was sort of using right here, like especially for the package here, right? This is just as effective. Okay. Just delete it all together, which is what they would like you to do. All right, so now we'll have to try to figure out how to get back into my presentation. All right. So Go's data types. Go actually has quite robust type system for especially for integer types. So just comparing it to Java and C#, especially for signed numeric types. Java's types are all signed, so it does not really implement unsigned integers. So you see that you've got your basic byte short. It uses this rune here as an alias for int32. Runes are basically the representation of a character in Unicode, and so that's what that stands for. And they just did that for the sake of if you're actually doing stuff like that, you can be a little bit more explicit about what you're doing, and everybody kind of knows. So int64s are longs. I don't need to read those off for you, but that's the basic. That's the basic idea. Unsigned integers. If you're not familiar with using unsigned integers, those are good for bitwise operations. Not very often do we need stuff like that, but if you were doing bit shifting and stuff like that, unsigned integers are probably better for that. All right. Before Nick gets too big of a head here, yes, you can do unsigned integers in Java. It's just that the representation is always stored as signed. Yes. Yeah, so.
I wasn't gonna come.
I gotta stand up for my Java. So other numeric types, there's just an int, and this is the one that you normally use when you're programming. Most people don't really require the type of precision to have to go into the figuring out whether you're going to use an int 8 or an int 16. If you're doing compression or stuff like that, you might care. So an int is a 32 or 64-bit signed integer. A unsigned int, or a uint, is a 32 or 64-bit unsigned integer. The difference here depends upon the chipset architecture that you're on. So if you're on a 64-bit machine, a 64-bit signed or unsigned integer will be slightly more efficient, and so that's why they use that. Same thing with 32.
That's a compile time thing? Or runtime?
That is a compile time thing. So it
So I
compiles.
build it on a 64-bit OS, it's going to be N64.
Yep.
Not N32.
But you would, if you're planning to deploy to a 32-bit machine, you would cross-compile it to that chipset architecture. So, the package directory actually makes that pretty clear. So if you dig into the package directory, it's actually going to show you your chipset architecture and your operating system that you're compiling for. So when you're deploying, you would just sort of pick the package that applies to wherever you're going to deploy to. A unit pointer is the unsigned integer large enough to hold a memory address, and the reason why they have this is escaping me at the moment, but that's basically what it is. It's a pointer. Unlike Java, especially, can you use pointers in C#?
Yes, you can use unsafe around it.
Okay, all right. So unlike Java, which sort of just covers all that up for you, you do have the option to use pointers explicitly in Go. I've not really covered that in this presentation just because it's just trying to cover a language. I gotta pick and choose which things I cover, which I don't. But that is, I think I do mention that a little bit. And there are some types, especially collection types, that are references or pointers by so you have, these are the aliases. A byte, obviously, 8 bits, a byte is an alias for that. And a room alias for int32, we talked about that being a Unicode character. So other Go types, it's got booleans and strings, obviously. Complex 64 is complex numbers are not things that we normally use, but those are, for completeness' sake, 2 float 32 numbers are a complex 64, and the same thing for 2 float 64 numbers.
That's actually
Yeah. And we're gonna start over again. Must have copied that twice. Oh, that was the one I wanted down there. So structs and interfaces. So structs are really just a way for you to build your own custom types, right? And they're composed of other small primitive types. So basically, if I wanted to create a cat, I would create a struct with a cat and then give it its properties. From there, I can attach functions to it, which are called methods when they're attached to a struct. An interface is really, we kind of talked about that earlier, that's sort of its method of polymorphic, or approach to polymorphism. Interfaces can either be a special interface, which is totally empty. It would be sort of like the object in Java, or some languages have an any, and that's kind of what that is. So interfaces are actually quite powerful. I don't really cover that a lot in here. But. All right, so flipping back to code less than I thought we would just kind of. Let's try this one. All right. So data types. So what we have here is, let's try this one in here. This one much better this time. All right, so talking about overflow. And this is actually, when you have this many different data types, especially for integers, you can have run into problems with overflow. This kind of talks about what's actually going to happen if you run into an overflow situation. So unsigned integer 8 has a capacity of 255. If you add 1 to that, what that's going to do is going to overflow to 0. Okay? And so then the same way you can underflow, so if you were to subtract from 0, you would end up with 255. Okay? That has more of a, this is a little bit of a contrived example, but if you are, for example, trying to assign the value of a number that's larger than like 256 to uint 8, you would end up with 2. Okay? So you have to be careful about that. If you just use ints, not a problem. You're probably not going to.
If I assign 257, will I get 1?
You get 1, yep. Let's see. So here, when I say that Go is serious about types, it's really serious about types, right? So both of these would fit within an int32. You cannot compare them for equality's sake. Go will not allow you to do that. So I can show you that really all I'm going to show you is just the here. So that error is invalid operation, y equals z mismatch types int 32 and 64. Okay. Now, if I go down here, now what I can do is I can convert and then compare equality, and that will work. Okay. Now this next here we're going to talk about something that's kind of all right. So here we have a struct dog. This is sort of how a struct is defined. All right, so and the same thing with interfaces. You would always start with a type, dog, and then give it the type that it is. So it's a struct. Again, here we are we're actually capitalizing all of the fields, just so that we can access them. You can implement something like an accessor mutator if you wanted to, but there's not really much point if you're not really going to use it in the way that you would, if you needed to modify a variable or a variable when you're putting it in, or modify a variable when it's coming out, something like that. You probably wouldn't do it other than that. So you can have different types. This is a slice. We'll talk about that in a little bit. But one thing is that, again, going back to circular references, you cannot put something of its own type inside within itself, right? So I cannot refer a dog to another dog. That would just kind of go dog, 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 all the way through the stack, and we'd have a problem. So the compiler will not allow you to do that. What you can do is you can use a pointer to a dog, or you can use a slice of a dog. Slices look like arrays, but they're a little bit different. We'll talk about that in a second. But they are essentially pointers. So effectively, you're doing something very similar there when you're doing those things. Now, here, this is actually the how you would add a method. So that is how you would add a method to a struct. Okay, so this could be a pointer or the actual value or the actual struct, and then you can add a method to it. Go will automatically dereference something that's been added to a pointer or to a value. However, you can give it, if you define one for both, you can give it different functionality based upon the pointer or the value. When there's only one assigned, it will automatically do dereferencing. So that's all done at compile time so that it doesn't incur any costs when you're doing it at runtime. So this basic the way the functions are defined. If you're adding it to a type, you would put that right here, and then your return type is right here. So for this function or method, we're going to return a string, and basically we're getting around that whole idea of having to call this string convert package every time.
So that gets rid of the keyword this.
Yes. Yeah. There's no this. And then down here, we have the animal interface. Now, the animal interface is implemented by dog. I'll kind of go back up here and show you that. But it's not explicit. So where in Java you would have something like, dog implements animal. The fact that dog has this method attached to it means that it now implements that interface. So this would be similar in concept in Ruby or a lot of untyped or non-typed languages. This would be a similar concept to that. Basically, it would be like duck typing. Familiar with that idea? If it's got something, walks like a duck, looks like a duck, it's a duck. Same thing, same concept here. And so up here we've got this log h function. This is a function that's just a function, not a method. So it's going to take an animal, and then because a dog has the right methods to call itself an animal, we can use dog here. In that way. So if I was to run this, so this is all the output. So UNA overflows to 0. That just is displaying that happening. So down here, where I've got my dog's name is Fido, my other dog's name is Spot. You can see up here where several of those are. That's all happening right here. And so you see how we get exactly the same result when we call ages string on the struct versus the string convert that's Attila on that actually.
So do these methods and interfaces, do they have to be in the same file as the thing that they're
They do not.
attached to?
They do not.
It seems so random that.
It does seem very random, especially when you're used to having it all kind of like neatly packaged up into one thing. The cool thing about that though is that if you're within the package, as long as you're within the package, you are able to modify anything like that. So it's very,
So it's not a total free-for-all.
right, yeah, you do have to be within the package.
Okay.
If you're trying to refer to something that you're importing from another package, you can't